This is example 4 from our 2-5 notes on inverse trig functions and solving triangle problems. So we start here. We are imagining that we are on a salvage ship in the Gulf of Mexico. So we talked about this in class. We identified that we are in a boat which is on the water. So here's the boat, and here we are. And there is a sunken ship which would be at the bottom of the sea, and that ship is at a slant distance of 683 meters from our sunken ship. So we've got this sunken ship here at the bottom of the sea. We're told that our sonar has located that ship at a 683 meter. We've got that with an angle of depression of 28 degrees. And this angle of depression is from the horizontal going downward, and we know that that is 28 degrees. So our first job in A is to find the depth of the water at the location of the sunken ship. So that would be the perpendicular distance from the water level to that sunken ship, and we'll call that D. So we need to, for A, we need to find D, which is the depth of the water, right, at the sunken ship. So we see a right triangle here, and we have our angle, and we have the hypotenuse, and we are trying to find the side opposite. So opposite hypotenuse, that would be sine. So if we set up the equation that the sine of our angle, 28 degrees, will equal the opposite side, which is our unknown D, divided by the hypotenuse, which is 683 meters. If we come in here and multiply both sides by 683 meters, that divides out on the right, leaving us with D equals what we get when we multiply these two together. And I put that in my calculator, and I get 320.649, and because this was in meters, this would be meters, and we have answered A. For B, we are asked how far we must go for our ship to be directly above the sunken ship. So we're really looking for this distance from where we are to this location. So let's call that F. So I want to leave this up, so I'm going to erase this to create some space here. Yours, of course, is on your paper. And we're going to come in here, and for B, we want to find F, which is, right, how far we must go. To be over that sunken ship. So to find F, F is my adjacent side to my angle. I know my hypotenuse, let's use cosine. So we would say that the cosine of 28 degrees equals our adjacent side F divided by our hypotenuse, 683 meters. So if we multiply both sides by 683 meters, we get that F is equal to this product, and if we put that in our calculator, we get 603.053 meters. So that's our answer to B. For C, we are told that our ship will move horizontally towards that sunken ship, and that after 520 meters, we're supposed to find the angle of depression. So we know that this entire distance is 603.053. So if our ship is going only 520 meters, maybe it's going from here to here. So that's our 520 meters. And our angle of depression, right, would be the angle going down to that sunken ship. This is the angle we're looking for. And now if we focus on this triangle, we know the opposite side, right? We found that in part A, that opposite side is, right, 320.649 meters. We know that this side, right, this piece from here to here, we can find by subtracting our 603.053 and our 520, which if we do, we get 83.053. So I'm going to create some space here. And for C then, we're looking to find theta, which is our angle of depression, right, after going 520 meters. So I want to find my angle. I know my, right, this side right here, which is my adjacent side. I know this side right here, which is my opposite side. So I can use tangent, and I could say the tangent of theta is equal to the opposite side, my 320.649 meters, divided by my adjacent side, which is my 83.053 meters. Those meters divide out. I want to solve for theta, so I take the inverse tangent of both sides. We know from property of inverses that when you put a function inside its inverse, what one does, the other one undoes. And that leaves us with theta alone, right? I do inverse tangent of this number, and I end up with 75.479, and that is in degrees. That's my answer for C. So D says, how could the crew of a fishing vessel use the techniques of this problem while searching for schools of fish? Right? I think that you could see this happen, that if they, right, don't find a sunken ship, but find a bunch of fish swimming around, that they could and would use trigonometry in order to determine where they have to go to catch those fish. All right, here you go. I hope you get this and understand. I would anticipate that you do a problem like this on your review, and you might look for having to solve a problem like this on your test tomorrow. See you then. Adios.